Hey everybody, today we're doing the second part of writing your hypotheses, which is writing your hypothesis using symbols. Okay, so if you haven't already watched the one on how to do it using words, you should do that first. So these notes are the same notes as Monday's. All I'm doing is I'm just trying to add to them to explain an example of how to write your hypotheses in symbols. So the first thing you need to note is when you write your hypotheses, they should always be about the whole population. That's a really important sentence I put here. So when you're writing your hypotheses using symbols, you should not have hats in your hypotheses. What I mean by that is no p hat, no x bar, because a hypothesis should not be about a sample. You can take a sample and you can find the mean, you can find the standard deviation, you can find anything you want out about the sample. What our hypotheses are always about is the whole population, because that's why we're taking a sample in the first place, is to give us more information about the whole population. So don't forget, make your hypotheses always about the whole population, okay? So we're going over here to this example, which we did last time. So the hypotheses are already written because we did the example before. So it says, a recent survey shows high school students use phone, whatever, on average 3.4 hours a day. An SRS of 50 RHS students shows an average of 3.6 hours per day. Is there evidence of a difference? So for our HO, we basically want to say that nothing has changed. It's the no difference hypothesis. So what we wrote right here is we wrote there is no evidence of a difference. So we're saying that there's not evidence of a difference, that the average phone use is still 3.4 hours per day, or that it hasn't changed. Our HA is whatever the researcher in the problem is trying to prove. So in this problem, our whole hypothesis is there evidence of a difference? So we think that the average phone use has actually changed from 3.6. From 3.4. Don't make that mistake. You think that it's changed from 3.4 because that's the mean. So our HA was that the phone use has changed, or that there is a difference. And the reason why it was just, is there a difference, is because right here in the statement, it didn't claim to know whether or not it had gone up or whether it had gone down. I know some of you guys are looking at this number right here, 3.6, and being like, well, obviously it went up, but you can't say that, okay? Because this is just a hypothesis. We're not drawing any conclusions yet. We're just learning how to write hypotheses. When you get to the end of the problem and you learn the math, I promise you can write a conclusion, but we're not there yet. So please don't mention anything with this number here, because that's about our sample and we haven't gotten there yet. Okay, so make sure your hypotheses are about the whole population. What is the population in this problem? If you don't know what the population is, it's kind of hard to do it. So the population in this problem is all RHS students. Okay, everyone who attends RHS. That's the population, okay? So you want to make sure you correctly identify which one is mean and which one is X bar. This is a mean problem. Sometimes you're going to have proportion problems. The reason I know this is a mean problem is because of the word average. You see the word average twice, and it's not talking about a percentage. So now that we know it's a mean, identify which one's mu and which one's X bar. Remember, X bar is about the sample. This is all going to matter when you write your hypotheses. So since X bar is about the sample, you want to ignore that number completely. We're going to focus in on mu, which is about the whole population. In this case, the population was high school students. Oops, the population isn't even all RHS students. It's just all high school students in general, because if you guys see what I underlined in blue, it was about all high school students. So let's just take that R off. Okay, so when you're writing your symbolic one for HO, you always want to include this, the equal sign. It should always be that the mean or the proportion of the whole population is equal to some number. So in this case, we're going to claim that the average phone use for high school students is what number? The mean here is 3.4. So if nothing has changed, then the average high school students' phone use should still be 3.4 hours a day, meaning the mean should be equal to 3.4, assuming the number has not changed since they did that study back in the day. So that's going to be how you symbolically write HO. Now we need to write HA. Again, you should still be writing mu is equal to, well, not equal to, sorry, let me take that back. You should not write equal to. You're going to actually choose from one of three symbols. You're going to choose from greater than, less than, or not equal to. The number that you put down here should be the same. So we're going to keep it as 3.4 because we're not trying to say that now the new mean is 3.6. That's not what we're trying to say. We're just trying to say whether or not the mean has either changed, increased, or decreased. So you have to read the question. Please don't look at the numbers. This is not about what X bar is. We don't care what X bar is yet. We're not there yet. So all we're trying to figure out is based on the wording of the sentence, is the sentence asking about an increase, a decrease, or a change? So in this case, if you guys see what I highlighted in yellow, it says, is there evidence of a difference? So is there evidence of a difference does not claim to know whether the number has increased or decreased, okay? It doesn't say one way or another. Yes, I can see that the number has increased, but that's not what I'm talking about right here. I'm talking about a hypothesis, which happens before we know all the rest of the information. So out of these three symbols, because it said, is there evidence of a difference, not an increase, not a decrease, but a difference, you should be using the not equal to symbol. That'll go right here. And this is how you write your hypotheses in symbols, okay? So we're going to do one more example. On the next page, we did this example. Suppose a healthcare provider knows that 48% of patients get a flu shot in the last year, got a flu shot. They used a new advertising strategy and found in a sample of 100 students, 49% had got a flu shot. Is there evidence that the new strategy worked, that it was effective? Okay, so you're advertising. If anyone advertises, would they want more people or less people to get the flu shot? Now, keep in mind, these are the healthcare providers. So they want people to take the flu shot. That's their whole goal. So if they're saying, if you guys can see right here in yellow, they're saying that they used a new advertising strategy. What that means is that they want more people. They want more people to take the flu shot, okay? So there's a couple ways you could write HO and HA. You could either say for HO that the new advertising strategy doesn't work, that there's no change, and that still 48% of people get the flu shot. The alternative is that the new advertising strategy does work, which would mean that more than 48% of people take the flu shot. So you could say it either way. Now, when we're doing it with symbols here, first thing right up here, if you guys can see this, decide if it's a mean or an X bar problem. In this case, this problem, did I say mean or X bar? I'm losing my mind. It's a mean or a P problem. So P for proportion. In this case, we're talking about the percentage of people who have done something. So if we're talking about the percentage of patients that got a flu shot, it's obviously going to be a P problem, okay? So you know you're dealing with P when you write your two hypotheses, okay? So I'm just going to go ahead and put a P here. Oops, wrong one. I'm going to put a P here, equals, and then I'm going to put a P down here because both of your hypotheses should be dealing with P, okay? Please make sure you find the difference between P and P hat. P is the percentage of all patients who got a flu shot. P hat is the percentage of the sample that got the flu shot, because P is about the whole population, P hat is about the sample. You're going to have to be able to tell those apart. So since the population is all hospital patients, you're looking for that. So where is it talking about all patients? Right here. This is not talking about a sample. It's talking about all patients. 48% of patients got a flu shot. So this number is P because it's about the whole population, whereas this number down here, it's talking about the SRS of 100. That's going to be P hat because it's your percentage of your sample that got a flu shot, okay? So ignore this number. It's not about that. It's about the whole population. So according to our symbols, we need to write that our P is still equal to 0.48 because that is the population proportion of patients who got a flu shot last year. Now you want to decide out of these three symbols, which one should you be using? So remember, it said, is there evidence the new advertising strategy works? If it works, there's going to be more people taking the flu shot. So more people would be a greater than symbol. Keep the number there the same, and it's going to be 0.48. So that's it for that. If you guys are good, you can stop there. Otherwise, we did one more example right here. So again, it's about identifying your p-value, your p-hat, and then also figuring out like what your two hypotheses are going to be. So you guys can read through this one here. This is about the first problem that we did. So it says, out of a sample of 100 students, my study showed that 57% drank alcohol. Okay, that number right away is P hat because it's talking about the sample of 100 students. If you keep reading, it says, suppose that a previous study had shown that 55% of all RHS students, meaning the whole population, have tried alcohol. So that's going to be your regular P. Is there evidence to suggest the proportion of students who've tried alcohol has increased? There's your key word right there, has increased, okay? So basically, you could write your HO two ways. Either the proportion of students who tried alcohol has not increased, or you could say 55% of RHS students have drank alcohol. Why not 57? Well, because the 57 is about the sample, and our hypothesis should be about the whole population. So our HA should always be the opposite of our HO. Make sure you correctly identify P and P hat. If you don't, that's going to cause you a lot of problems. So normally P comes first, but in this example, you had to be careful because it actually was talking about the sample in the first sentence and the population in the second sentence. So make sure that your symbols always are about P, not P hat, which is the whole population. So it's either going to be that 55% of RHS students have drank alcohol. This right here is what states that. It shows you right there that the percentage of RHS students who drank alcohol is equal to 55%. Whereas here, you have to decide again which symbol to use. And luckily for you guys, I actually highlighted that. So it says has increased. And therefore, I knew to use the increase, the greater than symbol in my conclusion, which is the same as saying more than 55% of RHS students have drank alcohol. Thanks for watching. Text me if you want me to read any of your sentences or check anything for you. And come to tutoring tomorrow if you need more help. Thanks, guys.